what we're going to do now for the rest of the day is to focus on each of those layers that Mayank and Piyush talked about. So, for example, the platforms, and then the applications, the visualization tools, and so forth. So there's exciting startups through the day speaking on these different topics in a format of either lightning rounds, or panel discussions, or fireside chats. There's also a session towards in the afternoon around how to be a data scientist, which is important. If you're in the analytics world and you're thinking how to become a data scientist, please come to see that one as well. It's very important, very interesting. So what I'm going to do now is introduce Mike Gualtieri from Forrester Research, and he and his panelists will talk about the big data platforms. So Mike?
Thank you. Hi, everyone. We're going to talk about the big data platform. Okay. With me here today is Eric Baldeschwieler. Did I say that right?
Baldeschwieler, yes.
Baldeschwieler. Eric is the CTO of Hortonworks. Also have with me Max Schireson, who's the CEO of Tengen. How you doing, Max?
Great. Happy to be here.
And finally, I have Shashank Tiwari.
Hi.
You're a senior architect at GE?
Yes, that's right.
Great.
Thank you.
So, Shashank, let me start with you. What is GE doing about big data, and what is your role in it?
Okay, excellent. So I'll try and keep it sort of brief because we try to do many things, so I don't want to segue into a kind of a more GE conversation. But the interesting thing is that GE is a company that is among the oldest that is out there, that is still on the big companies that have existed through the changes, from Great Depression to the war to the emergence of technology to today. And the funny thing is that GE really is still in the core businesses. So it is still doing things like making jet engines and powering things like water and gas distribution and things like locomotives and just the core industrial sectors. And what we realize as a company is that our next growth is really going to be when we tie in all these machines, which have become very smart of late. For the lack of a better word, they basically have all sensors and they have a lot of automation out there. And how do we harness all that data that we are collecting, right? And how do we kind of connect them together to make them even more smarter, where we have predictive analytics, where we are able to sort of be smarter about more uptime, where we are able to actually build a whole so-called industrial internet.
This is interesting. This is interesting because a lot of big data conversations focus around like marketing data or marketing use cases or sales use cases, and this is a solidly industrial use case. And isn't there like a big data center of excellence, or what has GE done formally, or have you done anything formally to embrace this opportunity?
Yes, we have. So we have a completely new center actually based in the Silicon Valley on the East Bay in San Ramon. And the idea of that center is just to tackle this problem. It's a center which now employs close to about 400 to 500 people. I may have my number off. But it's got a bunch of different people with different specialities, a lot of people with big data experience, people with data science experience, people working on the integration bits, people working on the machine-to-machine conversation. And the whole idea is to build this infrastructure for the industrial internet, so to speak. So yes, I am, I guess, one of the people who is sort of impacting and building that platform out there.
Eric,
that's that,
Eric and Max,
sure.
Thank you. Eric and Max,
Thank
let me get to you guys. Before we came on, there was a frightening slide with about, I don't know, were there like 2,000 logos on there with different companies, including your companies. And we're here to just kind of discuss the platform. What do you, Eric, let me start with you. What do you think sort of the core components of a big data platform should be?
There's obviously a lot of components, and it depends, but we certainly believe that Hadoop is a very core component to a big data strategy, especially if you're dealing with just collecting and processing huge volumes of data. So that's obviously the focus of Hortonworks.
Let me just push on that a little bit with Hadoop, because Hadoop is it correct to say that Hadoop is fundamentally a batch processing environment, and so that it's not really capable of handling sort of real-time analytics? So would that be at the center, or would Hadoop actually be sort of some background engine?
So yeah, I think that's a fair point. I mean, we like to say that Hadoop is kind of a +1 in a data architecture because Hadoop's origin is definitely in batch processing. It's used incrementally in interactive ways as well. But what we tend to see is that people don't rip out the infrastructures they already have, and so you will have, you know, your customer-facing serving infrastructures, wherever the sources of data around your company. People tend to collect that, process it, and then stage it into other systems. And those other, where your data workers will interact. So often Hadoop is kind of a backstage component in a larger architecture.
Right.
And so you'll see interactive components before and after Hadoop often.
Yep. Max, let's go to you. So your main product is MongoDB, the NoSQL database, and NoSQL certainly has a role. And would you say it's correct to say that Hadoop is kind of a category in itself and NoSQL is a separate category? Because I know a lot of people get confused. They say, oh, well, Hadoop is NoSQL. I guess technically it is, but it seems like it's its own category. And Max, let me ask you that, and Eric, chime in if you like.
Sure. Sure. So what we're focused on is providing a platform for people to build interactive applications.
So transactional.
Big data.
Yeah.
So it's operational, transactional, real-time, general purpose development environment, but one that embraces the volume, velocity, and variety of big data and works in a scale-out architecture. And I think that's a very challenging task. I think it's an exciting one, and I think it's an important part of the ecosystem along with Hadoop, which gets used for both, I think, a lot of complex analytics, but also a lot of ETL-type tasks as well, where things come through Hadoop and you've got this massive flow of data and you're trying to find the 1% that needs to be loaded into a database for more interactive activities, and pulling that out and putting it in the right format's important as well, as are some of the visualization pieces, for example, with the Tableau IPO today, I think reflects the importance of that layer as well.
Yep.
Yeah, just to enhance that, what we see is often sort of an adoption life cycle where people will start out with a product like Hadoop just as something like an ETL engine or a storage offloading environment, where they're just looking at a sort of cost reduction scenario. I can keep more data more cheaply, I can process more data more cheaply. And then as they sort of learn the technologies and the way to interact them, you see these kind of complex analytics use cases show up where they'll generate new reports, go explore that data interactively. But generally, Hadoop's strength is that you can look at 2 years of data at once and reorganize it into a format that makes sense. And then the sort of last stage that we see is sort of production applications, where you'll often see interactive systems in Hadoop interchanging data on a very frequently, where frequently would be defined in terms of minutes, 5 minutes, 15 minutes. And that's where you see, you know, Hadoop will be used to classify all of your customers' interest levels, and then you'll load that up into a serving system where the web pages will consult that serving system to serve a particular customer in a particular moment and refine the view of the customer instantaneously.
So you're saying that Hadoop does have kind of a real-time role?
Well, what we see is hybrid. I mean, what we see is combined architectures where Hadoop and interactive systems are combined. And in some of those systems, Hadoop will be used in an interactive capacity. There is a NoSQL store called HBase, for example.
Right.
But in many of those, there's many other NoSQL stores that fit some use cases better. And in fact, data warehouses, data discovery systems. So often Hadoop will be used to prepare data for those systems in short batches, and then those systems will do the direct interaction.
Shashank, how do you think about a big data platform at GE, and what are some of the components?
Sure.
Name names, name technologies that you guys are either POCing or actually using.
Right. So I think the correct straight one-line answer is we are pretty much looking at everything. Because
Yeah.
you know, we obviously don't want to go early and commit to something.
Yeah.
And then
So you think we're early?
I think so.
Yeah.
So let me kind of step back a little bit very quickly and see that. So there are some problems for which solutions have emerged as leaders. For example, Hadoop. I mean, today if you want to do a high throughput computing, you just have lots of data, let's say a petabyte of data.
Yeah.
You know, the most sort of the apparent option, the easy option is to start leveraging Hadoop. So there is a very sort of established baseline or a least common denominator, if you may, and which is why Hadoop has become sort of that in the industry. But then as you start going up from there and say, well, I want to do some interaction with traditional warehouses. I want to start looking at more real-time transactional data. I want to start looking at streams, and so on and so forth. So the use cases can go on and on. And I think that's where you've got a lot of other specialized solutions, which vary from NoSQL-based solutions, like the one Max has at Mongo, to solutions from the traditional database vendors, which is now going down the route of Hadoop and NoSQL, right, with the extensions. And then everybody else in the middle, there are the ESP guys and the people who traditionally did just stream processing, and then.
And are you guys using Hadoop now?
We are. So we certainly are Hadoop users, and if I know correctly, and if I have my facts right, Hadoop was actually being experimented and used even before this whole initiative was formalized, because Hadoop's been there now for a few years. So it was being used in various setups. What we are trying to do is we're trying to basically look at Hadoop to the next level, where we're saying, well, we've got some core infrastructure pieces from the open source that is already there, so we don't have to reinvent the wheel, but we can build the value-added stuff that is specific to our domain. For example, signal data. So can we build sort of, a store which is more proprietary, but at the same time works on top of Hadoop, but which is very good for signal processing, things like those. So we are trying to innovate on the segments that is sort of, more relevant to us. Just one more small bit I'll add on, and I'll have, in fact, Max and Eric chime in, because they must be seeing a variety of use cases, is that I think Hadoop itself is also evolving. So certainly it's the king of the batch processing world, but it's kind of going down the route of being interactive and then sort of nudging towards real time. Now, obviously, there are some core pieces of the stack which were never built out to kind of support those use cases. But I think there's a lot of innovation, a lot of sort of hybridization. I believe Mongo and Hadoop also talk to each other through the bridge. So in all this kind of bridging that's going on to, sort of get to the other parts of the story, where we have interactive use cases, real-time use cases, and everything else that gets covered.
When we think of like business opportunity for, say, entrepreneurs, let me start with you, Eric. What sort of business opportunities are there, technologies that are sorely needed in the whole Hadoop ecosystem that someone could really create another logo on one of that big slide we saw?
I think, the skies are the limit. There's huge opportunities in this area. Especially just in terms of, it's one thing to have a sort of data fabric where you can store your data, process your data, but to make that consumable to the enterprise, people need sort of vertical applications. They need solutions for their industry. And I think that big data infrastructure is really allowing people to rethink how they're going to solve some fundamental horizontal problems. You see things like customer relationship management, et cetera, but also vertical problems. If you look at why Hadoop has been so successful in the internet space in the Silicon Valley, for example, is because you can really attack advertising and search and all of these problems very differently with more data. So just taking that understanding to a vertical, you can add tremendous value.
Are there so vertical solutions, but are there any sort of technology gaps? Like let me give you an example. Cloudera talks a lot about Impala. And as putting a SQL layer on top of Hadoop that perhaps is faster than Hive and other things. Is that a key area of opportunity?
I think that's a key
area.
area.
And what's Hortonworks' answer to that, by the way?
Pardon?
And what is Horton's view on SQL on top of Hadoop?
So our belief is that SQL itself is solvable in the context of Hadoop. We have SQL in Hadoop solutions from the open source community, and those are evolving quickly as well. So there's something called Hive, originally built by Facebook. Right. So that's what we think is probably the best Hadoop SQL solution. And we expect to see that improve sort of 100x in terms of latency in the next year or two. There's a lot of really exciting work there. In terms of opportunities, though, like I said, horizontal, lots of opportunities in the analytics space. We see lots of interesting companies coming up providing visualization tools, business and analysis tools on top of Hadoop.
Like Plat4, for example,
that's an example of a
tool. Yeah. And there's many others. Yeah. And Max, what about MongoDB? You said it's for interactive applications. Well, so is traditional, Oracle.
Sure.
or SQL Server. And I mean, those, is Mongo replacing those, or is it an additive technology?
So we're certainly not going to entirely replace those, but I think there are a lot of use cases where MongoDB or other NoSQL databases make more sense than relational for that use case, right? And we've been in a world where really relational was the only choice for a couple of decades. And I think as these new solutions get out there and gain critical mass, I think people will be able to match the right tool for the right problem. And I think that there'll be, as with Hadoop, a big ecosystem around these new technologies. You know, if you think about the relational database world and Oracle and all the development tools and reporting tools and ETL tools and management tools and backup and recovery tools and service providers and everything that exists around that to enable millions of developers to be productive with that technology and end users to take advantage of it. I think we'll need similar ecosystems over the next decade or two in the NoSQL and Hadoop worlds.
And in thinking about these technologies, NoSQL, traditional C, like a lot of people don't understand why are those separate?
Sure.
Why can't Microsoft SQL Server just put a NoSQL capability in there? Why can't you just configure it and say, I want it to be this way? Is that something that's going to happen, or is there some fundamental reason why it's not happening?
So I think we see some of that happening already, right? So Oracle released a NoSQL database, and what we've seen is relatively little impact in the market from those technologies for two reasons, which is one, I think they've been relatively superficial attempts to solve the problem. They haven't really been big, deep engineering efforts to think about what is the data model that people want to use to represent data that's more flexible and agile, and what's the scale-out architecture that goes with that. So it's been a pretty simplistic solution, one. And then the second thing is that I think people are drawn to open source and the openness and the price points. I think that one of the challenges, if I put myself in the shoes of an Oracle exec, right? The question is, how aggressively would I want to go after this market, and how aggressively would I want to cannibalize my core product that I'm used to selling for $250,000 for a server in a market where the going price point is somewhere in the $5,000 to $10,000 range? Why would I really aggressively get behind that? And so I think there's some innovator's dilemma there as well, economically. But we've got over 100 engineers at 10gen working on MongoDB, and I expect that number will continue to grow dramatically over the coming years. We'll probably spend $1 billion over the next decade building out all the functionality that people need in a database, but one that's built on a different data model and for distributed deployments from scratch.
So Shashank, let's talk about G a little bit more in terms of some of the stuff, the industrial use cases, and there's lots of devices, and we know that streaming is a very important part of big data too, capturing all of this data. And I can imagine that G has tons of data that it can capture. Are you looking at technologies for capture, and how are you thinking about that?
So that's a very good question, actually. So the problem is at multiple levels. So there is capture, analytics, analysis at the machine level itself. There is some of that happens even today. A lot of that is around the PLC, SCADA type of environments where you have basically the core sensors, and there are a bunch of players and technologies there. We certainly are trying to innovate, and we have some solutions in that space. The next level is when you start aggregating it. So for example, a classic example would be aviation. So GE is one of the largest makers of jet engines out there today, and a substantial player in that market. So what happens is with every jet engine, there are a whole bunch of sensors. When I say a whole bunch, there are actually hundreds and thousands of sensors in every single jet engine, around rotors, blades, and every other part. So a lot of data gets collected. So every flight for any given fleet, let's say United Airlines flight from San Francisco to New York, probably ends up collecting a humongous amount of data. Sometimes, if you do it to the minutest detail, it could run into multiple, gigabytes and terabytes of data in a single flight. So you do collect a lot of that data. Now, the question for us is, essentially have analytics at different levels. We want to know some things are real time to make sure that it's a safe flight and it's a good flight. Then there are some things we want to know from a standpoint of long-term analysis. We want to make sure that we are very
For product
efficient
improvement,
engines.
you mean?
Product improvement,
Efficiency.
efficiency of engines, engine uptime, maintenance, and everything else around it, right? So there are analytics that would relate to that. And then there would be analytics like trending, predictive analytics, because as you see, how does the same engine perform one fleet versus the other, on one engine versus the other, one without servicing with servicing, right? So all those things that you could do.
And do you have the streaming technologies now to bring all that in and process it, or is that fundamentally what you're working on?
We have some of those in place. In fact, we also have some businesses which G has acquired over the years in that segment. So there are some existing businesses that cater specifically to streaming data from the sensors up to the machine to collection points. But yes, we will be doing a lot more there. We are looking at a lot more possible options there, right from event streams to kind of big data streaming. Or in some cases, we are also looking at solutions where we would have some analysis on the fly as it is being streamed, and then we'll run batch analytics again, sort of for larger data sets. So there are those hybrid models.
And Eric, where's Hadoop progressing in terms of data capture, streaming large amounts of data? How does that work in Hadoop?
How does it work? Well, there's a lot of progress and a lot of innovation there, actually, in terms of just, the key thing with Hadoop is simply the capacity. It has lots of bandwidth, it has lots of processing, it has lots of storage. So it's easy to put the data in. Now, there's a series of people building tools around that problem, right? How do I collect data from 1,000 devices, get it into Hadoop, et cetera? So there's lots of innovation there. Actually, if you have a moment, I wanted to go back to the previous question about Hadoop versus other vendors.
Yeah.
I think it's actually really interesting because we actually have deep partnerships with several traditional database vendors.
Right.
And they see that as very complementary.
Right.
Because there's some, those products solve business problems that Hadoop and Mongo don't, and do it in a very good and cost-effective way. But there's this whole new dimension of the problem, which is with these kinds of open source scale-out technologies, Mongo, Hadoop, et cetera, you can now keep much, much, much more data cost-effectively. And that's where the opportunity to innovate lies, right? Which is what he was talking about. It's not so much that you can do what you were doing more cheaply. It's that you can start with petabytes of data that you were just discarding, and that allows innovation. And it's really that opportunity to, it's the time to new value that's so exciting, not cost reduction, but discovery, new product, faster innovation. And just to pull that back to streaming and such, a lot of what's exciting is not capturing the data, but keeping it once you capture it. And because in Mongo and in Hadoop and all these other technologies, you don't have to make a lot of upfront decisions about what data, how you're going to structure the data, how you're going to clean the data. It means that you can just keep all of the data.
Right.
And then as you learn more about the data you're capturing, you can adjust your downstream processes. With a traditional data architecture, you need to know what question you're going to answer up front.
Yeah. And then you need to throw away data that you don't necessarily need. Yeah, that's a very good point. I've noticed that just in what you were saying that I've talked to many companies who have who their architecture is just that. They seem to be putting in Hadoop to break down data silos but without making decisions about the data. But then they seem to do some processing, whether it's ETL or some sort of processing, and then bring it into a traditional database because the power of doing SQL queries as well. And I talked to Pandora, who has a 200-node cluster, pour everything into it. They do a little Hive to pull out some data sets. They pull some of those into Postgres. They do some querying on top of that. And they do some visualization elsewhere. And so that just spells that this is additive, all of these technologies, and disruptive in a different way. It's not disruptive in that traditional technologies go away. It's disruptive in terms of what businesses can actually do with the data.
Yeah, no, the thing that really caused Hadoop to explode in its early days within Yahoo, where we built it, was we were able to turn to people and say, we're capturing all of the live user data feeds and all the advertising data feeds from all the Yahoo properties and keeping it in a central warehouse. So people would say, how do I have a new product idea. I want to start using Hadoop. So how do I do that? right? And we would say, well, we'll give you an account, and tomorrow you can build your application at full scale on Hadoop, see if your idea makes sense. You can know that in a few weeks, and if it makes sense, then we'll talk about procuring more hardware, like the specialized downstream systems to make it product speed at the end. But you can prove your whole idea with our existing infrastructure. And that's the difference between going from idea to idea validation and business case in weeks versus idea to procurement cycle. And that's sort of that agility revolution.
And I think Mongo has a similar use
Absolutely.
case for agility too in terms of schema freedom.
Absolutely. We really excited about a use case that one of our customers just announced at MetLife. They had 24 different customer service phone numbers because they had 70 different customer service systems, and they couldn't train one set of agents how to use all the different systems.
Yeah.
And so, this is not limited to MetLife in the past, right? Any big organization you call and you get bounced around from department to department, trying to get somebody on the phone who can actually access the data they need to answer your question. And so what they were able to do, they did a proof of concept in a couple of weeks and brought it into production in 90 days. They poured all the data from the 70 customer service systems into MongoDB and built one system where their agents could see everybody's data. And they actually built the user interface modeled off of Facebook's wall so they could train people on it really easily. And so this is every insurance company has wanted for many years to get all that data in one place to be able to give customers better service, but it was that schema flexibility that made that project practical, right? Theoretically, you could map it all and put it into a relational database, but it would take years, and by the time you were done, the schema would have changed.
Yeah.
And we're seeing that across many industries. We're doing a project like that with some of the biggest telcos. We're doing it in finance, in intelligence, just across the board. People are finding that agility and ability to combine data from different silos cost effectively is revolutionary.
Absolutely.
Yeah, I was just pushing on sort of what this can do for the consumer as well. One of the things that we learned from our customers at Forrester is that the goal of most companies is to get much more personal with their customers. It's pretty standard practice to create personas of your customers. So you have 2 million customers, but you kind of pick six representations. And some think that that's barbaric, right? What if you could know more about each customer? I was at Google I/O earlier this week, and they showed their new search capability where I can say, when's my flight? In the Google text box, right? So if it knows that calendar, it's the Google Now stuff. And so is this sort of the type of personalization that companies are going to be able to do with this technology?
Now that's a very loaded one, I guess. I don't know whether technology itself will solve the problem or not, but I think the aspiration is there. Yeah. I certainly feel that, I also feel that what has been happening in the sort of traditional Silicon Valley consumer space with, starting off at Yahoo and Google and then going on to everything else beyond that, Facebook and Twitter and LinkedIn and everything else, I think the bar has been raised. So as consumers, we all have tasted the good stuff.
Right.
So I think that larger companies also realize that consumers want that. So it's no more about not giving consumers, but just playing the catch-up game. So I think, in some of these, for example, Max's use case that he mentioned, that you need to have better customer service and thereby bring everything together. Right. Doing it the traditional way typically has been very expensive anywhere, because then you have to do data migration efforts, you have to do schema manipulation efforts. I mean, it's just a humongous task that involves too many people, too much time, money, energy.
And where do you think we are on the maturity curve here in terms of really using this? In terms of using any of these big data technologies, I talk to two types of people. Some that are kind of obsessed with storage. I've got to store all this sort of stuff. And then I talk to some other people that are kind of obsessed with the machine learning algorithms, which is sort of mining the data. I mean, clearly both of these are important. But where are you guys seeing on the adoption curve? And how long will it take before this is mainstream? Does everyone need Hadoop right now? Should they wait?
I mean, there's a lot of ways of talking about that. I mean, in some sense, you could certainly say that Hadoop has crossed the chasm in the sense that it is really being used across many, many industries by most of the players in a lot of the industries. At this point, I mean, most of the Fortune 500 companies are using Hadoop in some way.
Yeah.
But that said, it's just the beginning of, I think, a revolution that's going to, really digesting these technologies and the other technologies that are coming at organizations at the same time, virtualization, cloud, et cetera. I mean, putting all these things together and finding the most value is a journey that's going to take years. Like I said, we need to build the vertical solutions that make this consumable. We need to build the software as a service solutions that are going to make this consumable. So I think that there's years of innovation that these platforms are sparking. So these platforms are now mature enough that they can be deployed and add value, but there's still, it still takes a lot of training and a lot of learning to figure out how to find the most value. And to deliver these platforms as they mature is going to take an ecosystem around them. And I think that's the opportunity in this space.
Yep. All right, well, thank you, Eric. Thank you, Max. Thank you, Shashank. And thanks, everyone.
Yeah.
Thank you.